People naturally fear the end of pretty much anything. We don't want our favorite shows to end. We're sad at the end of books. We won't let our game series end. We fear the ends of our childhoods, youth, friendships, and lives. Cast your view further, and the end of our world and solar system terrifies people. They'd rather not think about it, pretend it won't happen. And that's why I'm here. I love endings. Nothing bores me more than a never-ending story. Not that one. Well, screw the third one. Anyway, this is why I'm here for you today. We're going to start our contemplations here, at the biggest ending, the end of the universe, and all three possibilities it entails. And maybe we'll achieve some clarity, and understand why they might not be something to be feared. But first, let's gloss over the beginning. There are a few things we know about the beginning of the universe. It was hot, everything was much closer together, and everything was flying out from one relatively small spot at ludicrous speeds. This is the foundation for the shaky Big Bang theory, a theory full of likely unfillable holes, but it's the best we've got so far. But regardless of where it all came from in the first place, all that we need to know is those first few points, and that they're pretty much proven. Now, after that, the universe continued to grow. Like a rocket escaping Earth, its force overpowered gravity, and it continues to expand outwards at an increasing rate to this day. Pushed on by a force we don't yet understand, but we just call dark energy, the universe expands faster and faster all the time, instead of slowing down like everyone thought it would. And here we come to a question. Will gravity eventually overpower the mysterious dark energy? Or will dark energy continue to grow in strength and continue to push the galaxies apart? Both of these avenues lead to a different fate, so let's explore an order of probability. First, the increasingly unlikely chance that gravity will get its grip back and pull galactic clusters back together. If by chance this happens, then we get the most hopeful scenario, the Big Crunch, and its little friend, the Big Bounce. If eventually gravity manages to grab onto everything and dark energy evens out, then things will play backwards. The various galactic clusters will come back to each other as the universe shrinks, slowly at first, and then quickly, like a wave that crashed against the shore of the universe and now has to recede. As everything bunches back together, the universe gets brighter and hotter as all of its endless components come back together. Eventually, everything is broken back down into basic elements, and gravity is so strong that all of it is pulled back together into the greatest singularity of all creation, a black hole containing our entire universe. This is the Big Crunch. But perhaps not the ending. That singularity would be incredibly unstable, might even end up exploding. Something like that going would be a pretty big bang. Oh, wait a minute. Yes, the likely end result of the Big Crunch would probably be another Big Bang. Everything was gathered up and recycled, and now souls will flourish anew, and all this will play out again. We might just be yet another cycle in an ever-reincarnating universe. Now isn't that a thought? A perfect cycle where every ending brings about a new beginning. I'm willing to argue that this is the most beautiful view of the universe, and a good video would stop here and end on a positively thought-provoking note. Now, let's see the ever more likely events in which dark energy continues to overpower gravity. If dark energy continues in its endless quest to push galactic neighborhoods apart faster than light, and gravity can't rein it in, a battle it's clearly losing, then things will continue to drift apart forever. There's actually two paths that this way can follow, and continuing on from least to most likely, let's talk about the Big Rip. The Big Rip is about as unpleasant as it sounds. In this scenario, whatever dark energy is, pushes gravity to its limits and pushes apart more than just galactic clusters. First, as the fabric of space is stretched by the universal expansion, even galaxies and gravitationally close families will be thrown apart. Then the stars in those galaxies will begin to fly away from each other, and then things like stars would dissipate. Planets, objects, everything throwing itself into particles across emptiness. At the very end, even atoms would fly apart. Gluons, neutrinos, quarks, and all their kind would scatter across the universe. Just as the galactic clusters are moving away from each other faster than light, so too would all these particles. And since all of them are still limited to the speed of light, none of them would ever meet to form energy or matter again. The universe would become dark, an endless void, teeming with every lonely, zooming subatomic particle there ever was. That felt a lot more dismal than the last one for sure, huh? Well, as far as we can tell, the Big Rip isn't likely. We just don't know enough about dark energy to say for sure, but so far it doesn't seem to have that much power. So let's jump to the most likely scenario. Hold on to your hats for the Big Freeze. This one also follows the path of dark energy overpowering gravity, leading to eternal universal expansion. Everything is pushed further apart, but our detour from the Big Rip begins, or rather doesn't begin, with dark energy overpowering gravity on a smaller scale, and galactic groups get to keep themselves together. The superclusters get pushed apart, but places like our local group get to stay together. This pattern would repeat across the universe, across all the now scattered islands of light. And eventually, all stars do and will die. They shed their outer layers, and all that collects with other gas clouds and forms new stars. But each time, there's a little less. Eventually, there will not be enough gas left in the universe to ignite a single star, or at least the amounts that would be needed won't be anywhere near each other. Stars will stop forming, and as remaining red dwarfs die, the universe will fall dark. Remaining gases will decay through long, slow radiation, as will neutron stars, black dwarfs, black holes even. Eventually, over unfathomable amounts of time, the universe will have no more matter remaining, and will be an empty eternity. So, that's the Big Freeze, where all heat and energy in the universe winds down through entropy, energy's tendency to spread itself evenly. For this reason, it's also known as the heat death of the universe, but Big Freeze, despite not being a descriptive or even accurate name, lined up better with the other names, and sounded a little less depressing. This is the most basic version of this I could get into here. There's more little details and nuances to each of them that are really worth talking about, but all I wanted to do was lay a groundwork. You thought these endings to the universe were scary? I can think of something even scarier. Join me again, and I'll tell you what I think is scarier than the end of the universe. And galactic loop, a big fat greedy nincompoop.